In this video, we will go step by step through the process of solving inequalities involving both x and y. We will cover graphing the solution set on a coordinate plane, determining boundary lines, shading the regions, and interpreting intersecting areas for a system of inequalities. Let's look at an example. Y is less than or equal to a half x plus 2, and y is greater than negative 2x minus 1. We'll graph these inequalities step by step using a coordinate plane. First, graph the boundary line for the inequality y is less than or equal to a half x plus 2. Since our inequality is less than or equal to, we'll plot a solid line. Next, test whether a point such as the origin satisfies the inequality. Since 0 is less than or equal to 2, we will shade below the blue line where the inequality holds. Now, let's graph the boundary line for the second inequality, y greater than negative 2x minus 1. Since it's greater than, we'll use a dashed line. Test a point again to determine the region where the inequality holds true. 0 is greater than negative 1, so we will shade above the red dashed line. Finally, the solution set to this system includes the points satisfying both inequalities, which are located within the intersection of the two shaded regions. To conclude, solving inequalities graphically involves graphing boundary lines, deciding whether the region attached to them is solid or dashed based on the equality sign, shading appropriate areas, and finally identifying the intersection of these areas.